Alright guys, welcome. In this video, we're going to be talking about using graphs to help us solve some problems involving exponential functions. So here we're just going to do one quick example, and we already know how to do two parts of this problem. It's the third part that we're not really equipped, or we might be, but maybe we're not equipped with the algebra skills to solve this third part yet, part C. So this problem tells us that the half-life of a chemical is 5 hours, and we know 500 grams of that chemical is introduced to some environment. All right, so we're just going to write the function to model this situation. Of course, we are going to be modeling the amount of that chemical left after t hours have passed. All right, so I'll write this function as p of t is equal to 500 is our initial value. It's half-life, so 0.5, to the t divided by 5, because it's having every 5 hours. So after one full day, how much of the chemical is present? We know to solve this problem, and I'm not going to write out what the actual answer is, but to solve this problem, we would just plug in 24 for t. Excuse me. So to the 24 divided by 5. Boom, we type that in into our calculators, and we solve. So then part C is how long will it take for less than 10 grams to be present? Well, let's think about it. I'm not going to be plugging that in for t. I'm going to be trying to solve for t. So I'm going to want to plug that into my p, my final p value. So I'm plugging that in on the left side. I'm saying, all right, I want less than 10 grams. Well, let's find when is it going to be exactly equal to 10 grams. So 10 is equal to 500 times 0.5 to the t divided by 5. All right, well, now let's solve this. We start by dividing by 500. So I divide by 500. I get 1 over 50. Okay, 1 over 50, or 0.02, equals 0.5 to the t divided by 5. And now it's just like, wait a second, how on earth am I going to solve this? Right, my variable's in the exponent. At this point, unless you're familiar with logarithms, you're not really going to be able to solve this using algebra. All right, once we cover logarithms, sure, you'll definitely be able to solve for t using algebra. But for right now, we can't really do that. So we need to think of some other method. Well, let's start off just by thinking about, well, after how many hours, how much is going to be left? Right, we know it's having every 5 hours. So if we start with 500, I know after 1 hour, I'm down to 250. Sorry, that's after 5 hours, I'm down to 250. After 10 hours, it halves again, I'm down to 125. After 15 hours, it halves again. We're going to say that's 62.5. So then 20 hours, we're down to about 31.25. 25 hours brings us down to 625. And then when we have it again, boom, that's going to drop us to like 7.8125. All right, so we can see somewhere between this 25-hour mark and this 30-hour mark, that's when we hit 10. Well, so that kind of gives us an idea of what our correct answer should be, but how do we get the exact answer? How do we know exactly what our answer should be? This is where graphing is going to come into play. So we're going to start by saying, well, we know 10 has to equal 500 times 0.5 to the t divided by 5. Well, that just means if we graph this function, we're just trying to figure out, well, when is the y value equal to 10? So what we can do on the calculator is we're going to graph this on the right, we're going to graph that, and we're also going to graph the function y equals 10. Once we do that, we can use an intersect button on the calculator to see where do these two functions intercept. So let's go ahead and take a look. We'll go to the calculator, and we'll get there eventually. So in the calculator, I go ahead and I type both of these in. Y equals 500 times 0.5 to the x divided by 5. and then y equals 10. So initially, if we go to our graph, if I go to the graph, we're just going to have, this is likely our normal window is negative 10 to 10. So negative 10, 10. Oop, not auto 10, 10. All right, our normal window, nothing's really happening here. What are we going to do with this? Well, we need to change our window. We know that we're looking for some value that's between x equals 0 and x equals 30, right? We found it was x equals 30. If you want to be safe, we could just hit like 100. And then for my y scale, well, it should be meeting at around y equals 10. So maybe I want to see just a little bit more than that. I'll set my y max at like 50. All right, so now when I graph it, I should clearly be able to see, well, here's my exponential function, here's my just constant y equals 10, and they intersect somewhere there. So now we're going to use that calc button that we love to use. Second, calc. All right, and we scroll down to number 5 here for me is intersect. It might be different on your calculator, but maybe it's the same. I hit intersect, so I just want to scroll to the left of that intersection, hit enter. Scroll to the right of that intersection, hit enter, and then on your calculator it says guess, and we hit enter again, and then boom, we get the intersection is 28.219, 10. So that x value is our answer, right? When t is equal to 28.21 or 22, then my p of t is equal to 10. So we wind up getting t is equal to 28.22, I think it was. So at 28.22 days, that's when we're going to have 10 left. If you want to use Desmos for now, that's fine. So using Desmos, same exact thing. You guys can see here, I just typed in our first function, then I typed in y equals 10, and boom, Desmos just gives us that point immediately of 28.219, 10. So again, that 28.22, that is our solution to the problem.